Welcome to the Explainer. You know, our world is basically a giant jumbled of mixed up stuff. I mean, think about it. Your morning coffee, the air you breathe, it's all a mix. So today, we're going to become detectives and figure out the clever tricks used to unmix it all.
So let's start with this puzzle that is literally all around you. The air you're breathing right now, that's a mix of gases. The salad on your plate, a mix of veggies. The ground under your feet, a mix of sand, soil, and rock. So, how in the world do we start pulling these mixtures apart to get what we actually want?
Okay, to get started, we got to get two key ideas down. On one side, you've got a pure substance. It's made of only one thing, like pure gold. But on the other side, you have a mixture, which, let's be honest, is what most of our world is made of. It's just a bunch of different things physically blended together. And here's the secret. In a mixture, each part keeps its own identity. That's the key that lets us pull them apart again.
All right, let's kick things off with the most straightforward puzzles, separating solid things from other solid things. These are the kinds of challenges you can often see with your own eyes.
Here is a classic problem. You've probably even seen this in your own kitchen. You get a bag of rice, but whoops, there are some tiny, unwanted stones mixed in. What's the most direct way to get it clean before you cook?
Well, the most obvious solution is usually the simplest one, right? Hand picking. We can do this because we're taking advantage of a really obvious physical difference. The stones are a different size, a different shape, and a different color. They're just big enough to see and grab. Super low tech, I know, but for a small job, it works perfectly.
But what happens when the pieces are way too small? Or there are just too many of them to pick out one by one? I mean, imagine a construction worker trying to get pure sand from a pile that's full of pebbles. Hand picking? Yeah, no way. That would take forever. There has to be a better way.
And this is where a super simple tool comes in to save the day. And it's all about one thing: particle size. Sieving is just brilliant in its simplicity. The mesh in the sieve, it acts like a gatekeeper. The smaller sand particles get to fall right through, while the larger pebbles, they get stuck. It's the perfect solution for sorting a huge amount of stuff fast.
Okay, let's head over to a farm and see how they solve a completely different kind of separation puzzle. So after the wheat is harvested, the valuable grain is all mixed up with this light, papery stuff called husk. Now they're roughly the same size, so sieving is out. What property can they use now?
They use this clever and actually ancient method called winnowing. The key property here isn't size, it's weight. By tossing the mixture up into the air, the wind just carries the lightweight husk away, while the heavier grains fall straight back down. Simple, but you have to admit, that's incredibly effective.
Now for a more unusual problem, one that highlights a really specific, almost magical physical property. Just imagine, you've spilled tiny iron filings all over a pile of sand. They're too small to handpick, they're too heavy to winnow. How on earth could you possibly separate them?
The secret here is to find a property that one of the materials has, but the other one doesn't. And in this case, that special property is magnetism. When you pass a magnet over the pile, the iron filings practically leap out of the sand to grab onto it. It looks like magic, but it's just science. But, and this is a big but, this trick only works because iron has that one special characteristic. You couldn't do this with sugar and sand because neither one is magnetic. Okay, the challenges are about to get a little trickier, a little messier. We're moving on to separating a solid that's just floating around in a liquid but won't actually dissolve, like mud and water.
For something like muddy water, we can use a little 1-2 punch. First, you just let it sit. That's it. Gravity does all the heavy lifting, pulling the heavier mud particles down to the bottom. That process is called sedimentation. Then, once everything's settled, you carefully pour off the clear liquid on top. And that step is called decantation.
But, this process isn't always perfect. Some of those mud particles are so tiny, they can just stay floating around for hours. And when you go to pour off the top layer, it's really easy to accidentally stir up some of that settled mud. So for truly clean water, we often need a more precise method.
And that's where filtration comes in. Just think about making your coffee or tea in the morning. You use a filter that acts like a barrier with microscopic holes in it. The liquid is able to pass right through, but the solid particles, like the coffee grounds or the tea leaves, they get trapped.
So this process actually gives us two different things, and they have these cool, official scientific names. The solid stuff that gets left behind on the filter paper, that's called the residue. And the clear liquid that makes it all the way through, that's called the filtrate. Two totally distinct products from one simple process.
All right, now we're facing what might be the toughest puzzle yet: How do you separate something you can't even see, something that is dissolved completely in a liquid, like salt and water? Filtration is useless here. Those tiny salt particles will sail right through the filter with the water.
So to crack this one, we got to learn the lingo. The liquid that's doing the dissolving, in this case water, is called the solvent. The stuff that gets dissolved, like our salt, is the solute. And once you mix them together, you get a solution, which looks completely uniform, totally clear.
So how do you do it? Well, it's a two-part trick that involves two opposite but related processes. If all you want is the salt back, you can just heat the salt water. The water will turn into vapor, steam, and float away, leaving the salt crystals behind. That's evaporation. But what if you want the pure water back? Well, then you have to capture that steam and cool it down so it turns back into a pure liquid. That's condensation.
And this isn't just a textbook idea. People use this to survive. A solar still is this incredibly clever, simple device that uses the sun's heat to evaporate salt water. The pure water vapor rises, hits a cool plastic cover, and then condenses back into fresh, clean drinking water, leaving all the salt behind. It is an absolutely elegant solution to a life or death problem.
Okay, so we've looked at a whole toolbox of different methods now, from picking things by hand all the way to evaporation. So how do you know which tool to grab for any given job? Well, the answer is always hidden in the properties of the mixture itself.
This chart really brings it all home. As you can see, for every single type of mixture, there's a specific property we can exploit to pull it apart. It's not about choosing a method at random, it's about being clever and matching the tool to the unique characteristic of the puzzle, whether that's size, weight, magnetism, or whether or not something can dissolve.
And that really is the big takeaway here. Separation isn't about memorizing a long list of methods. It's about learning to think like a detective. You have to look at the evidence, the mixture, and identify that one crucial difference between the parts. And then you select the perfect tool to crack the case. So that leaves us with one final thought. Now that you see the world as a whole series of separation puzzles, from filtering your coffee in the morning to watching dust settle out of the air, what mixture in your world are you going to look at differently and solve first?